We're now starting the next section, section 6, which is areas of regular polygons. The formula you need to remember for this is area equals 1/2 AP, where A is the apothem, and that is a line that goes from the center of the polygon out to one of the sides. So in this case it's GF, and the perimeter will be, of course, adding all of the sides here. You notice there's a circle here. This is just to give us a framework on which to get everything. For this problem, we want to find the angle measure AFB. So if we look, we have A to F to B. Now if I draw a line here, a line here, a line there, we've now broken up. If you ignore, give me one sec here. If you ignore line GF, which is the apothem, if you ignore this line right here, we've broken up this circle right here. If I drew a circle, we've broken it up into 1, 2, 3, 4, 5 triangles. That means that each of these angles should be equal. To find the measure of angle AFB, in this case, since there's 5 angles, you notice there's 5 sides, so there's 5 angles. So to find this, we would do 360 divided by 5, and 360 divided by 5 is 72. 72. Okay, so that means that this is 72 degrees. That's 72 degrees. This is also 72 degrees. This is also 72, etc. So each of those angles is 72 degrees. And if we added all of those, it should equal 360. So 360 divided by 5 is 72. The next thing we want to find is angle AFG. Now remember, we told you this whole angle here was 72. Since this is an isosceles triangle, you can tell because those are both radii. That means that this line right here is an angle bisector. It's also an altitude. It's also a perpendicular bisector. But the important thing is it's an angle bisector. So since this whole angle is 72, that means that each of these angles are 72 divided by 2, or 36 degrees. Okay? So again, back up. So FG is the apothem, and it makes an altitude. It bisects this angle, so it's half of the angle, 72, so that's 36. For this next one, we want to find GAF. Remember that we just stated that this was 36 degrees, and since these two angles add up to 90 degrees, we can say that this angle GAF is going to be 90 minus 36, or 54 degrees. Okay? And they did it the long way, but remember these two add up to 90, so that makes this 54. Now, we're just tying in bits and pieces of what we're going to need to know in order to do these types of problems. It says identify the center. The center would be P. Identify a radius. That would be either XP or YP. We want to know the apothem. The apothem in this case is PQ. Segment PQ, we should say. Central angle of the polygon is angle XPY. So that's this angle right here. Okay, so again, the center is P. The radiuses are PY and XP. PQ is the apothem, and the central angle is angle XPY. For this next one, we want to find more angles again. Remember that we want to know what XPY is first. So if I draw a line here, and I draw a line here, and ignore the fact that this one is here. Okay? If I do that, each of these angles should be equal. So this one is found by doing 360 divided by 4, which gives us 90 degrees. Erasing this, we want to know what XPQ is. Well, if this whole angle is 90, we know that these two angles are equal. Therefore, this angle right here, which is XPQ, would be 90 divided by 2, or 45 degrees. So that's this one. And then we want to know this angle right here. Remember, this angle is found by doing these two angles add together to 90, since this is 45 degrees. This one right here, which is this, would be found by doing 90 minus 45, which in this case happens to also be 45. 90, 45, 45. And we're done here. Thanks.